Hi guys. Um, so in the previous slide, in the previous videos, we defined how to calculate mean or average. So we are going to apply the method to this example. In this example, I'm going to consider a car dealer, and we would like to evaluate the dealer's performance. So the data is the past records of the dealer's weekly sales. So how many cars, simply speaking, how many cars the dealer sold in each week. So in the past 50 weeks, suppose that the data are given in this form, which is a frequency distribution table. So this means that like among the past 50 weeks, 25 of them, the salesperson, the dealer, did not sell any car in those weeks. And in 20 weeks, in 20 or 50 weeks, the seller sold one car. So the seller could sell one car a week, and 4 weeks, in 4 of the past 50 weeks, the seller could sell 2 cars in a week. And when the seller was extremely lucky, the seller could sell 3 cars a week. So this is, you can think it as a frequency distribution table. And from here, can you calculate the probability that this seller, this dealer, sells 3 cars a week? It should be simple enough. Do the simple algebra, and if you need more time, pause the video and answer it by yourself. Now I'm going to turn the page. So here is the answer. We need to, in the end, we need to calculate the average of the weekly sales. But here, as a first step, we need to calculate the probability first. So first thing you have to do is to calculate the sample size. Sample size is the sum of these 4 frequencies, or already I gave you because I said the data are from the past 50 weeks. So the underlying experiment is to choose a random week, 7 days, and see how lucky you are, or how good the economy is. So then automatically probability is simply the ratio between the frequency and the sample size. So 25 out of 50 is 0.5, and 20 out of 50 is 0.4, and then in that way the probability that the outcome equals to 3 is 1 out of 50. In this example, that means the probability that this car dealer sells 3 cars a week is 1 out of 50, which is 2%, or 0.02. Then, okay, that was just a review of how we calculate the probability. And now let's calculate the mean weekly sales. So it takes more time. Remember think about which method you have to use. Like I explained in the previous video, I told you that there are 2 different methods. If you have raw data, you have method 1, and if you have frequency distribution table or probability distribution table, you have to use method 2. Think about it and do the math and answer this question. I am going to turn the page. If you have not finished this question, then pause the video again. What you need to do here is to apply method 2. You need to use the method 2, and the idea is we need the sum of probability weighted outcomes. What we need is probability weighted outcomes, and that's obtained by multiplying the outcome to its probability. So 0 times 0.5 is its probability weighted outcome, which is 0, and outcome 1 is weighted by 0.4, which is 0.4. 1 times 0.4 is 0.4, which is the second probability weighted outcome, and 2 is weighted by 0.08. If you multiply, it becomes 0.16, which is another probability weighted outcome. And finally, 3 times 0.02 is another probability weighted outcome. So there are 4 probability weighted outcomes: 0, 0.4, 0.16, 0.06. So this is intermediate step. Then you have to sum these probability weighted outcomes. The sum of the weighted outcomes is the mean. And the seller, so from this, you can get the mean equals to 0.62, which means this dealer sells on average 0.62 cars a week on average. So sells more than 0.5, sells more than 1 in 2 weeks, but less than 1 in a week. So that's how we calculate the mean. It's simple, and if you get the idea, remember the mean is the sum of probability weighted outcomes. Then it's just a matter of some algebra. Just get used to it and do more exercise. And I am going to make this question a little bit more complicated and more realistic. We are evaluating this dealer. We would like to see whether you have to promote this dealer, or you have to fire this dealer, or need more, like some more incentive or whatever. So we are going to make 2 more assumptions. First, suppose that selling a car generates a profit of $3,000. So you, when you sell one car, the profit that comes to the owner is $3,000. But the owner, the dealership owner, has to pay the salesperson, the dealer, weekly as much as $2,000. So we have to think about if the salesperson, this dealer, deserves that salary. That's uncertain. Like, let's look back at the data. So in 25 weeks, this dealer does not generate any profit, but still you have to pay the fixed salary. Like, if suppose that you are the owner, and in a week when this dealer did really well, still you are paying the same $2,000. So then you are making more profit. But then we would like to determine, okay, sometimes it's true, sometimes the dealer is doing better than his salary, but other times the dealer is not doing as much as his salary. So then, is the salary appropriate, or too much, or too low? What should we do? What we are going to do here is we are going to calculate the expected net profit. So it's a mean average net profit, which is profit minus salary. So profit to the owner minus the salary paid back to the dealer. How can we do this? That is a more important question here, and also interesting question. And what we are going to do here is simply we are going to convert the table, the original table, into weekly net profit table. So in the first table, we had a column named weekly sales, which was the number of cars sold in a week. And it was the possible outcomes were 0, 1, 2, 3. What we are doing here is we are going to transform these numbers into net profit. And we know we already have concrete numbers, so we know how to transform these numbers into here. And simply suppose the dealer sold 0 car, and then the net profit generated in that week was $3,000 times 0. So there was no profit made, but minus 2,000 salary paid. So the net profit is minus 2,000. When the dealer sells 1 car, generated $3,000 and took $2,000. So in that, the net profit is plus $1,000. Similarly, in that way, two cars imply plus $4,000 profit, and 3 cars imply plus $7,000 profit. So it's easy. It's so simple, like elementary school level math, algebra. So what you are doing is simply, you may think it as a change of units. In the original data, the unit was given in terms of number of cars, but now we are not interested in the cars, but we are interested in dollars. We are interested in the profit, so simply we transformed using our assumptions. Okay, then what's interesting here is these two are just different numbers, different way to describe the same event. So if there was a week where the seller sold 3 cars, you may describe that event as 3, as the number of cars sold. But instead, equivalently, it does not matter even if you label that week as 7,000. So they are the same thing. So 3 cars sold equals to making a net profit of $7,000. So it's one-to-one mapping. It's they are the same events. So this is important. First, we are defining a new random variable. We are describing the same event with different numbers. That's one point I'd like to say. And another point I'd like to say here is this is the clue to calculate the probability for the new variable. We need to calculate the probability for this new variable, and the probability is coming from this idea. So if you understand that 2 variables are basically the same events or using different labels, then it's easy to understand. The probability for the weekly net profit is simply inherited from the original variable. So the probability that net profit equals to minus 2,000 is the same probability of selling 0 car in that week. So we use the probability of selling 0 cars in a week. So we have probabilities which are the same as the original probability, because as I said, what we are doing is simply renaming, labeling the same event. So there is no reason to change the probability, underlying probability. And then in this case, we are ready to calculate the average net profit. Do that. Determine the expected weekly net profit given this probability. As I said, it's obvious now you have to use method 2, which is to calculate the probability weighted outcomes and sum them. So do the exercise, and I will stop this video here. And after working on this problem, please then after doing this, watch the next video. Thank you for watching the video. Good luck.